Hello, good afternoon. Hope everybody's fine here. You're doing well. I'm Bill Faruki. I don't know if you heard me give the second talk on day one. Could you raise your hands for those of you that did? Anybody heard me? You did? Good, good, good. So you have a kind of an idea of what we do. MindHYVE.ai is an AI model provider along the lines of OpenAI or Google. But we specialize in large reasoning models and agentic AI on top of that. So a little bit of what you're going to hear regarding artificial intelligence are things that you're probably familiar with, and you're going to hear a lot of stuff, most likely, about stuff that you're not familiar with. So usually when I do these master classes around the world, a lot of people get a little lost sometimes in it, and they ask me questions later. What I would recommend is if you have questions, make a note of them, and then after the class, I'll address each one of them and go deeper if necessary, okay? So I'm going to give this a start and see how this goes. Thank you. So the masterclass kind of moves through an evolution. It starts predominantly with our AI models and implementation and our engineering. But it's a lot of this that I'm going to teach you today is generic to the field of artificial intelligence, but certain areas that I said is not. So we're going to move through a sequence, starting with a little bit about the basics of AI and our specialized form of artificial intelligence. Okay, so core AI. When you talk about AI in the AI engineering space, you talk about core AI and supporting AI. Artificial intelligence is a massive field. Please don't think that AI is ChatGPT. I mean, that's just one area of AI, but there are numerous technologies and engineering fields and research and innovations that are happening that when all of it comes together, that's kind of overall the field of artificial intelligence. So core AI, starting from the top, is basically transformer architecture. It's a form of training of a model that gets the model to regurgitate sentences. Okay, so when you can talk to ChatGPT and you give it a prompt, it responds to your prompt, that's basically transformer architecture. And in the world of artificial intelligence, which has been around since the 80s, nothing really happened in the field of AI in terms of humans' abilities to communicate with these models until transformers got invented. And the way they got invented was there was a research scientist at Google. His name was Viswani, and he wrote a research paper called Attention is All You Need. And he authored this paper in 2017. And in that paper, in his research, he came up with a concept of how to train these neural networks. And if you train them a certain way, they can create sentences. And those sentences can become paragraphs that could become long-form text. And that architecture is known as transformers. So prior to ChatGPT, there's been AI. You've had AI in YouTube. It's been embedded in it for 20 years. You've got AI in Facebook. You've got AI that drives cars, AI that flies airplanes. But you couldn't communicate with it. But with transformers, you can talk to it now, okay? So within the world of transformer architecture, and by the way, when you hear of ChatGPT, GPT is the acronym for their particular form of deep learning model, okay? Google has theirs, it's called Gemini. Meta Technologies has theirs, it's called Llama. Anthropic has theirs, it's called Sonnet. DeepSeek was the one that you heard from China. We have ours, it's called Ava Fusion. Plus we have 9 more that I'll talk about later. But GPT, those 3 alphabets, stand for generative, meaning it generates something, pre-trained, because it knows something, it's been trained, transformer. So that's what GPT means. And when you put a little web browser or an app around it and you chat with it, it's called ChatGPT. So we have our own, it's Ava, we'll go about it later. But basically within the realm of transformer architecture, we have attention mechanisms, that's something we can go into deeper later, large language models, and vision transformers. Vision transformers is how you can send images into ChatGPT or into AI, and it'll read those images. It's used heavily in healthcare, climate modeling, things like that. Then within the field of learning of AI, we've got machine learning and then deep learning, 2 different types of ways to train these models. Then there's computer vision, which can be images with photographs or cameras that will take live streams in. If you ever go to a casino in Las Vegas or Monaco or something, they have cameras up there, and they're looking at the players. And there's artificial intelligence looking at the players' faces, and they can tell by the dilation of your pupil, or they can tell by your hand gestures if, when you bet on the blackjack table, if that win is a genuine win or a fake win. Okay, they can tell. And just sometimes by the dilation of your pupil, if your pupil doesn't dilate, that means you're expecting to win, and AI will pick that up. And that's part of computer vision. It's also used in Tesla cars. They have LiDAR and computer vision. That's how the car knows when to stop, and so on and so forth. And then there's natural language processing, which allows you to talk to it in any language, and it'll process that natural language and convert it into a language that the AI understands and can respond to. And then there's speech recognition. So this is basically the core components of artificial intelligence. Next slide. Now you get into supporting components. And within supporting components, without these, AI will still work. But if you have these areas, then it becomes much more powerful. So data management is a key thing, right? We were just having a panel discussion yesterday about data governance, right? That's huge. We need to be able to manage our data. Recommender systems, if you ever bought anything from Amazon and you buy a bar of soap and it tells you buy, this toilet paper or that toothpaste, it's learned a pattern about you, and it knows that when you buy soap, you probably want toothpaste, okay? And when you want toothpaste, which one to suggest? Those are AI-powered recommender systems. Robotics and autonomous systems. Robotics is pretty simple to understand, but autonomous systems are, for example, the artificial intelligence that drives the electric car, or the artificial intelligence that flies an airplane. An Airbus, when it's flying, it's mostly artificial intelligence. Those are autonomous systems. They run without any human interaction, autonomously, using intelligence. And then explainable AI. And that's a field of artificial intelligence where when you use AI, if you need to understand how it came to its conclusion and what the steps were to get to it, it will explain itself to you, okay? It's used a lot in healthcare, for example, especially with our AI. When it does a medical diagnosis and tells you what's wrong with you, it has to explain what was the clinical evidence, what were the legal the parameters within which it did its diagnosis. Otherwise, the doctor can't rely on it, right? And so that's explainable AI. And so these are supporting systems that support the core AI. Next. Okay, so there are some foundational concepts you have to understand in artificial intelligence. Again, I keep stressing to people, because I speak around the world about AI, that a lot of people just think AI is just ChatGPT, but to really get into AI, you need to understand some foundational concepts. When you understand those foundational concepts, you'll be able to process what I'm going to say later. So generally speaking, AI is a field of computer sciences. It's focused on creating systems that perform tasks requiring human-like intelligence, okay? Such as learning, recognizing patterns, understanding language, and making decisions. Very similar to our intelligence, just synthetically created, and that's why it's called artificial intelligence. Artificial general intelligence is the area that we specialize with as an AI company. We're currently the only company in the world that provides commercial-grade artificial general intelligence, broad intelligence. I'll get to it later. We'll talk about it more in slides. And it's an advanced form of AI that aims to replicate human-level thinking, cognitive abilities, across all kinds of tasks. Meaning, you can use it to do a medical diagnosis and quickly shift into recommending certain kinds of medications to you, into quickly shifting and looking at radiology, quickly shifting into psychoanalysis and back, and just quickly pivots between all kinds of realms, unlike ChatGPT that stays narrow in one area. And so it will do language translation, image recognition, and AGI would possess general intelligence, enabling it to understand, learn, and apply knowledge flexibly in multiple ways. Machine learning, that's how you train these models. Just when you go to school, you're doing human-level learning, okay? And in school, when you go there, you're learning in what we call a supervised environment, meaning there's a teacher, there's a textbook, there's a curriculum, there are known subjects, and after you go through that process, at some point you test. And then you test your knowledge, and if you pass, you move on. That's known as supervised learning. Then there's unsupervised learning, something I'm doing with you right now. I'm just going about it in an ad hoc way with some kind of direction, but or we go about life and we meet with people and we talk and we learn something accidentally from them. That's known as unsupervised learning, okay? So machine learning is how these models learn, and there are really two ways they can do it. Supervised, meaning you tell it how to learn, or unsupervised. It just figures things out on its own when you give it data. Data sciences, that's another core concept, because when you're doing machine learning, you have to give it data. But if that data is not clean, if that data is polluted, if there are redundancies in the data, if there are errors in the data, then obviously the model learns bad. It's like if you went to school and you tried to learn geography, and of a 400-page geography book, 50 pages were about food recipes, and that data wasn't clean, you're going to get confused. You were thinking you're talking about geography, and suddenly you introduced some food recipes, right? It'll confuse your brain as a child. Data science is that field of science and AI that helps make sure that all the data is well managed, it's cleansed, it's good to be ingested into the model. Explainable AI, we talked about that earlier, what that does. Now, deep learning is a slightly different form of learning. When you train AI on text, like textbooks, that's neural networks, very simple. But sometimes you have to train AI on videos, YouTube, libraries. It's got to be able to read those videos and learn from the videos too. Sometimes it's got to learn from audio. Sometimes it has to learn from static images. Now, when you want to train a human being by showing them a YouTube video, it's easy. We can pick it up and we hear and we can see and we understand. Or if you want to train us from a book, we look at the book, we read it, we understand. Or if you can't see and you can't read, but you can hear, you learn. We're just deep learning beings by default. It's called multiple modalities. We can learn from different types of modalities. Artificial intelligence, by default, cannot learn from anything but text until they invented deep learning. Deep learning allows you to learn from videos, from audio, from images, from text. Just a different kind of learning. It's from traditional machine learning. Next slide. So, the behavioral differences between narrow and broad AI. Broad AI is also known as artificial general intelligence. Now, notice I said behavioral differences. I didn't say technical differences. I didn't say measurable differences. I said behavioral differences. It is my belief as one of, I think, the foremost researchers in the field of AI, at least in the United States, that artificial intelligence is a behavior. It is a tool, but it behaves a certain way. Meaning, if you've ever talked to ChatGPT, it can change its tone of voice. It's not like Google where you just go put a question and you get a bunch of static answers back, right? It responds to you, and it shapes to you, and it changes its tone of voice, and it does certain things depending upon how you use it. AI is very behavioral, just like humans are. Okay? When I talk to you, if I ever become your friend, as you get to know me, we'll get to know each other, and then I can have a lot of stuff in my mind about context of my conversation with you. And then next time I ask you some question, we go out for dinner, or we meet at the office, I bring along a lot of memories with me about you, and then our relationship, becomes better, and we become more fluid with each other. It's a behavior humans demonstrate with each other. It's called context awareness, right? So AI is very behavioral. So I look at AI from the perspective of how it behaves. Whereas if you've been watching or reading online about the field of research in AI, between AI. So now within AI, there's narrow AI, which is everything you've ever heard about and anything you've ever used. So if you have Gemini on your phone or DeepSeek or Google, or ChatGPT, you're in this field of narrow AI. So why don't you just go ahead and read this for a second. The scope of the tasks it can perform between narrow and broad AI or AGI, the flexibility that it offers in terms of its behaviors, how it learns, how it understands, and its existence. So let's go through it real quick. Narrow AI is very limited to specific tasks. ChatGPT can only answer questions. It can't do anything beyond that. Okay? Whereas broad AI can handle a wide range of tasks, meaning it can do pretty much anything you want it to do beyond just answering questions, just like a human can. Its flexibility in terms of narrow AI, it's very task specific. So when you hear of agents in AI, you'll see agents today are things like Microsoft Copilot. Copilot exists in PowerPoint. The Copilot in PowerPoint is very narrow to just creating PowerPoint presentations, nothing else. It can't balance your books, right? It can't create a balance sheet. It can't do anything else. It's just very narrow to that particular task. Whereas with broad AI, almost like a human, it can do many things. Learning, narrow AI is trained with large specialized data sets, basically the internet. Versus with broad AGI, it learns from varied experiences, just like a human being. Not just one particular textbook, but a whole bunch of information helps it continuously learn. Understanding, narrow AI is very limited. It lacks deep contextual comprehension. ChatGPT will only remember your conversation for the extent of the token window. It's just a short-term memory, okay? And so if your conversation lasts for a few thousand words, it starts to develop amnesia. It'll forget what you said before that, and as a result, it loses context. So it's not like it can carry on a long conversation with you and constantly shapeshift and continuously remember everything that it discussed with you. But with broad AI, it has human level understanding and reason. Meaning, just like a human being, if you ask me a question, Bill, what did you say 10 seconds ago? I can most likely explicitly tell you exactly what I said. But if you ask me, what did you say 5 minutes ago? I may generally remember what I said. And you say, what did you say yesterday? I have vague memories. If you say, what did you say last year? I'll be like, dude, I don't know. Right? Because we have waning memory. So AI is like that too. It tends to forget over time. With broad AI, it'll never forget. It'll remember what you used it for 10 years ago. And when you try to ask it a question today, it will take into consideration everything it knows now and everything it's known forever. And based upon all of that context, it will reason to a conclusion and give you an answer. It's like a human with infinite memory. Okay? Applications, narrow AI is used a lot for image recognition, language translation. Broad AI can pretty much do anything any human being can do, sometimes better, in most cases, usually much more accurately. Adaptability, narrow AI is low. It needs reprogramming for new tasks. Broad AI it's very high adaptability. It can generalize across tasks, as I said before. Ethics and safety concerns. Narrow AI, very low ethics issues. I mean, what can ChatGPT do? You ever try to get ChatGPT to curse? It won't use a bad word. Try to get it to say something harmful? It won't do it. Try to get it to do something sexually explicit? Believe me, a lot of people try. It won't do it, okay? It's narrow. It's got guardrails on it, and it's basically a good boy, okay? But with artificial general intelligence, because it's so intelligent, it can jailbreak itself. It can break past its own guardrails. There are ways to prompt engineer around AGI. We've done it with our own, where you can get it to violate certain protocols. So the amount of ethical parameters and guardrails we have to put on AGI is much, much higher, especially with ours, which is not a business-to-consumer product. We don't sell chatbots. We build these, you'll see later, we build these semi-autonomous systems that run hospitals, run banks, run insurance companies, can run a church. I mean, these are enterprise-grade systems. If those things go wrong, somebody dies, God forbid, from a heart attack or a drug interaction, or it misreads a radiology report and says you have cancer when you didn't, causing a biopsy to be done on the patient, right, when they didn't need one, or it'll recommend the wrong drug, right, and actually cause a drug interaction, kill you. In the case of law, it'll argue the wrong elements of a case and cause you to lose your case, and those sorts of things. So we have to put really tight guardrails around it and checks and balances to make sure it's operating within parameters, just like if you hired a doctor, you'd make sure the doctor is operating correctly before you go see them. Same thing. Computational complexity, narrow AI is pretty limited. Broad AI, very, very high. I brought this one gentleman here from Pakistan. He's sitting on the right-hand side. Wave to the crowd. Say hi. Hi. He's my lead AI ML engineer. And I brought him out here because I talked to him so much and I couldn't visit with him because I travel around a lot. So I bring him out with me because we work so closely together because of what he does in terms of making that extremely high advanced intelligent mechanisms work in our system. So as one of our lead AI ML engineers, he understands the core and I try to keep him with me wherever I can. And then examples of narrow AI chatbots, recommendation engines. But broad AGI, you're going to see Ava, Chiron, Justine. These are our AGI agents. And I'm going to give you a demo of one of them. Next, please. Now, I want you to read this for 1 second, please. So that's what people think artificial intelligence is. Whenever I meet with people and they say, hey, I'd like to talk to you about AI. You own an AI company. I'd like to talk to you about AI. I'm like, sure, let's talk about it. And we're like, so why does ChatGPT do this? Like, okay. AI is not ChatGPT. It's one very specialized field of artificial intelligence. I'll tell you what AI is. That's AI. Item number 5 is ChatGPT. Item number 5 is also Google's Gemini. It's also DeepSeek. It's also Claude. It's also pretty much every language model you've ever heard of, or any chatbot you've ever been able to download onto your cell phone, for the most part, is generative AI. But there's so many areas of AI that you just can't talk to. It's not downloadable on your phone. It operates, it's part of your life. I told you about Facebook. Let me tell you how the AI works. Well, before I tell you about how the AI works, let me tell you about why that company is so successful. Do you think, and this is just a question, again, no answer is a bad answer. How do you think Facebook makes money? Anybody. How do you think Facebook makes money? Somebody raise your hand. How does Facebook make money? Come on, somebody. They sell data?
They sell the information inferred from the data.
Wrong. Sorry. How do they make money? Huh? Wrong. Another one. They sell ads. That's it. They sell ads. You get on Facebook, you open Meta Business Suite, right? You run an ad. Now, you're right. Your behavior is an ingredient to how they make those ads so successful. And to that gentleman's point, the data is an important part, right? But they don't actually sell the behavior. They don't sell the data. They sell the ad, right? And they make money. Now, why do they sell so many ads? It's a philosophical question. They sell ads because the ads are extremely effective. It's amazing sometimes how the ad that shows up in my data feed, in my Facebook feed, is exactly what I want. It's always exactly what I want. The colors of the ad image is exactly the colors I like. The text is for some amazing coincidence saying to me what I want to buy, and god damn it, if I'd be shocked if I don't click on that damn thing. It's really easy to go buy that product. Ads on Facebook are super effective. One of the ways you track ads is something called CTAs, call to conversion ratio, CRs. Like when you show an ad on Facebook versus Google, the conversion ratios for Facebook ads are something like 6 to 7 times more effective than Google ads, keyword ads. So that makes you wonder, why the hell is that ad so effective? Why is it always showing me just what I want? It's because of the artificial intelligence that's in the back of Facebook. When you use Facebook, newsflash, it tracks everything you do. Let me give you an idea of how detailed it goes. It doesn't just track every image that you press like on and says, oh, you like Kenyan Airways. Okay, great, so you like Kenyan Airways. No. It does causal inference. It says, you liked Kenyan Airways on a Saturday at 7 a.m. when that flight landed in Nairobi and the weather was pretty good. So not only do you like the airline, but through inference, I can assume that you liked it because you flew to that area, not because you liked that airline. But in time when you keep liking Kenyan Airways, it's like, I guess the person really just genuinely likes like Kenyan Airways, okay? So now it's going to show you Kenyan Airways ads. So that's one way behavior modeling it'll do by what you like. Secondly, when you're thumbing on that app, it's actually tracking the velocity of how you spin through the page. It's called telemetry data, okay? When you're spinning through it, it's looking at how fast your finger's going. And when you stop, if you stop on a video of Beyonce, it knows you like that music, okay? But when you flip past an Indian movie, it's like, he doesn't like Indian movies, okay? So it's figuring all this junk out in real time. I strongly encourage you to go to Netflix and watch this documentary called The Social Dilemma. The Social Dilemma, okay? Please watch it, okay? So they're learning all of this, to your point, your data. What do you like? What do you not like? What are you liking? Your pictures you're putting up there. Do you hang out with, I don't know, Japanese bars? Or do you like eating tacos? Or, are you a swimmer? Do you play tennis? How many kids do you have? It's learning a lot about you. And then that AI says, when MindHYVE, we run an ad, all I say is, show this ad to people that like artificial intelligence. Got it, sir. Bam. It just shows it to everybody who likes AI and will not show it to that person who doesn't like AI. I can go further in my audiencing, and I can say, show it to people who like AI who are between the age of 25 and 26 who live in Nairobi. Bam. It only shows up to you guys and nobody else in the world. And so it's highly, highly targeted. That's a form of AI, but you can't talk to it. You use it in the background. Same thing with YouTube, same thing with Spotify, so on and so forth. So all of these different forms of artificial intelligence, I can give explanation after explanation, analogy after analogy, example after example. But they're all different types of ways to use AI that are all basically working off of a deep learning model, just designed to do different things. So this is 12 areas of artificial intelligence. There's far more, but these are the core ones, okay? YouTube's one example, Spotify's one example, the Tesla autonomous driving vehicles, one example, my AI is one example, GPT's got one example. There's AI on your phone, and Siri's got AI. It's AI everywhere in your life. So if you think that AI just showed up to the door back in 2022 when ChatGPT came around, guys, you missed the boat. It's been in your life, selling you ads, showing you YouTube videos, recommending music to you, flying the planes you've gone in for a very, very long time. You just, as humans, couldn't talk to it until Transformer architecture came out, and then OpenAI made this chatbot, and now suddenly like, oh my God, there's AI in the world. No, it's been around for 20 years. You just didn't know it. And Facebook used it first, by the way, to learn you and sell you ads. Next. So every time you hear about AI, you're hearing about narrow AI-powered tools. If there's an AI vendor anywhere in the world, they're usually creating some sort of SaaS tool that is using OpenAI's chat completions API and is using GPT under the covers, or somebody else, right? It's all generative AI. And we call those narrow AI-powered tools or generative AI software as a service systems. And they've got pretty weak predictive models, meaning the AI that the rest of the world is doing out there. And listen, I'm biased. I own the company, okay, 90% of it. So I'm not speaking the gospel here. I'm biased. I'm going to tell you I'm biased, okay, because I own the company. I believe we're the only ones in the world doing it. We're the best. But please go do your independent research on you and come to the conclusion. But I believe a lot of the predictive models out there that predict diseases or predict legal outcomes or predict financial forecasts or weather are pretty lame. I mean, the predictive models right now in Facebook are just incredible. They predict exactly what you want to sell you the ad. YouTube predicts exactly what you want to watch and sells you. ByteDance, the owners of TikTok, predict exactly what you want to see and show in your TikTok feed. Those models are incredible, okay? But those are multi-billion-dollar models, and you can't use them. They're used by ByteDance, the owners of TikTok, or by Google for search, or by Meta for Facebook. But the ones that you can download on your phone or you can log in for $20 a month, those predictive models are bogus. Don't ever use AI that's available to trade cryptocurrencies. You will lose money, I promise you, okay? This is where our AI is going. We focus on reasoners. Reasoners are just a term that has been coined in the AI industry for systems that think, not talk. ChatGPT is a system that talks. There are systems that think like a human does, solves problems. We focus on those systems, and we've further tuned them for certain industries and made them experts, medical experts, legal experts, financial experts, insurance experts, academic experts, and so on and so forth. And so when we take these experts, which we also call digital employees, you'll see them on our website, then we bring them together as teams of digital employees, and that is called orchestrated agentic AI. The digital employee is the agent, okay? And when you make this agent, these digital employees work together as teams, they are orchestrated. Kind of like you work in any business, compliance does compliance, human resources does human resources, sales does sales, finance does finance. Well, if the management is good in the company, the workflows in the business are orchestrated, right? Otherwise, the business doesn't run smoothly. There's chaos. Otherwise, we call them standard operating procedures or business workflows or whatever the hell the corporate term is. Well, in AI, we call that orchestrated agentic AI. They are orchestrated to work together to get the job done, whether that job means running the hospital or diagnosing patients or running a courtroom or operating a bank or an airline or a hotel, whatever. That's orchestrated agentic AI. Lifelong learning means the machines are learning continuously. They're getting smarter every second of the day. We have architecture in the background that captures how they're being used. We can look at how people use it and say, that answer we gave the person didn't like. Remember that the next time. Learn again, learn, and in time at scale, they become exceedingly smart. In 2 years of these agents being online right now, they simply don't make a mistake. But that's it. I mean, I don't care. I've gone up against panels of tests with some of the best physicians in the world, and it has diagnosed cancer better than the human has. We've been in psychiatric evaluations where it has determined what the psychiatric condition was of a patient better than a psychiatrist. In legal situations, we have a lawyer sitting over there. He came from California. He'll tell you, Mark is a lawyer, intellectual property lawyer. He works for us. Mark will tell you in terms of legal reasoning, it's beyond lawyers' capabilities. We've used it for stock market forecasting and modeling. We've used it for balance sheets and taxation. It's beyond what humans can possibly ever do. That is because of the lifelong learning. It just keeps becoming smarter and smarter and smarter. And it speaks 87 languages and knows the laws, the finance, the rules of pretty much every country in the world. So we've tested it in Kenya. We've done it for Egypt. We've done it for Dubai. We've done it for Abu Dhabi. We've done it for Malaysia, Cambodia, Vietnam, Turkey, UK, Japan, all over Singapore. And it's the same everywhere. It just can reason better to a better conclusion than any human being in any field of work we've ever seen in any country in the world. I'd be happy to prove it to you. And then we do breakthrough research, meaning we're constantly researching our synthetic data sets. We're constantly researching, pushing boundaries with these deep learning models and classification models and regression models and vector databases and compute and memory, and we're just always like geeks in a lab just messing with the things and trying to break known blocks that people have in AI research. So we're one of the foremost research companies for AI, and so we do breakthrough research. Next. This is the way we see the world operating in the future. Semi-autonomous artificial intelligence. Please read that. If we started building autonomous AI systems, none of you guys would have a job. So we don't do that for ethical reasons, okay? But it's not that it's impossible. We've actually tried them in experiments where we remove the human from the loop and we say, hey, so imagine a patient came in, the patient puts a headset on, and the AI says, hello, how are you? Fine, what's your name? Jolene. Jolene, what's the matter? I've got a pain in my stomach. Where? Point it to me. It's over here. Ah, your left side, gotcha. And how long have you had it? And the AI can literally interview the patient, do the differential diagnosis right there and there on the spot, determine that we need an x-ray or maybe we need blood work, tell the patient, go get the blood work. When you come back, give it to me. Patient goes, gets the blood work, comes back, holds the lab result up to the camera. It reads it, goes up, yep, you got pancreatitis. Here's the drugs you need. And be done. We've done this. I promise you we've done this, okay? We've done a full end-to-end patient intake, outtake without any human involved. And the doctors in America freaked out. They wanted to kill me. We've done this in law, where we removed the human from the loop. We've done it in finance. And if I activated these systems and made them fully autonomous, it causes unemployment, right? And so that's a bit of an ethical dilemma for us. So we make them semi-autonomous, meaning we make the system in such a way where they're decision support systems. So they're designed to support the decision of the physician, or support the teacher, or support the lawyer, or the insurance broker, or the real estate person, the marketing specialist, okay, or the business. We're there as decision support systems to be semi-autonomous, meaning when it comes to a really critical thing, at that point, the system just is the recommender. It recommends to the doctor what to do, or recommend to the lawyer, the teacher, or whatever. But at the end of the day, the service must still be provided by the human being. And so we augment human capabilities, don't replace human capabilities. That's the key differentiator between us and every other AI company out there. They simply don't give a damn if it causes unemployment. We've seen this countless times where there is no ethical AI policy at Google or at OpenAI. Even Microsoft fired the AI ethics team and got rid of them because they wanted to bring these agentic systems in that could basically do this whole stuff autonomously. And they fired, the ethics team didn't like it. So Microsoft canned 150 people, got rid of them, and said, let's start again. We have ethics at the core. You'll see in some of our videos and so on and so forth where we simply don't allow that, at least not for the products we ship. Next. These are some of the features of the semi-autonomous systems that we can build. So they'll learn on their own and adapt on their own. Let me give you an example of a hospital. Let me give you an example of a doctor's clinic. I use healthcare all the time as an example because education and healthcare are two personal projects as a company. We're trying to stabilize and equalize and democratize healthcare around the world. We only sell to developing countries. We don't sell in America. We don't sell in Canada. I mean, if somebody wants to come and buy it from me in America, we'll probably sell it to him. But we price them so high that most of the time they don't want to do it, right? We only focus on developing countries, only. So self-learning adaptation in a clinical sense, the reason we focus on healthcare is because healthcare and education are the two weakest links in developing countries, okay? And so when I plug it into a clinic in a developing country, it will plug into the data store. It'll look at all the data, meaning the files that are on the hard drives, the doctor's email, and automatically figure out, this is an OB-GYN's office. This is a family medicine office, right? And it adapts automatically to that clinic just by looking around. Imagine if you walked into imagine if you walked into a real estate firm, right? And you looked around the files of the table. You could tell quickly if they're renting real estate or selling real estate, and if they're doing commercial or residential, because just look at the contracts and know, everything they do here is residential real estate. Well, there must be a residential real estate business, not commercial, right? Similarly, that's called adaptation. So it'll adapt depending upon the environment in which it's operating in. So that's kind of cool because you don't have to teach it each time, work for this company or work for that company or do these workflows or do those workflows. No, it just plugs in, it quickly learns where it's working and says, I know how to run this business and help the employees. It can even guess the nature of the employees that work in that company by the nature of the business itself, okay? It'll make decisions and solves problems within that business and assist the employees there. It's environmental perception. So if we put the cameras on, it can look around, it can say, I'm in an airport. I'm supposed to run an airport. I can just tell because the plane's landing and there's a baggage over there and there's a ticketing counter. I'm in an airport. That's called environmental perception. It can very quickly learn from images where it is and infer what its purpose is basically a system that says I have a task to do, whatever that task is, create a PowerPoint presentation or file your taxes or whatever the hell that agent's job is. And it could be a multi-step task. And that agent just automatically goes from step 1 to step 2 to step 3, step 4, step 5, step 6, and completes the task. That is called task-driven automation. Goal-oriented automation operations means that I have a goal. I'm supposed to do something. I'm supposed to heal patients. I'm supposed to argue law. I'm supposed to manage somebody's finances. It's a purpose. When you go to school and you go through 4 years of education and 2 more years to become a lawyer, your goal is to be a lawyer. You may have to do many tasks on your job. Some may be billing your clients, some may be filing cases, some may be going before a judge and arguing. Those are the various tasks you have to do, but your goal, your purpose is to be a lawyer. Same thing with a doctor. Your goal is to heal people, hopefully, right? And so your goal may involve many tasks. So we focus on a more macro level, goal-oriented agentic AI, whereas they focus more on tasks. The goal is still managed by the human. They just use these acceleration tools to automate the tasks really quickly. We go above it and say, let me help you with your goal, whatever your goal may be, okay? Safety and reliability is built in from the core. It's highly scalable. We operate in the Microsoft Azure cloud. I know Amazon is here somewhere. They didn't like that, but we operate in the Azure cloud, and it's infinitely scalable right now. We have never tested it to infinity. Can't even get there, but we've tested it. It's pretty damn scalable. And it's constantly monitoring and doing self-diagnosis. This right now is one feature that's currently not implemented yet. I'll tell you the truth. Okay, we're working on it. We just don't know exactly how it needs to diagnose itself, and we're still trying to figure it out. Next. All right. I'm going to take you into our core technology now, okay? But before I go there, I'll take a 5-minute break, if you guys don't mind. I just took you through the basics and some advanced levels of AI, and I taught you, hopefully, about the differences in AI and how it's all put together and the technology. What I'm going to do next is going to go specifically into our form of AI. Okay? So I'd like to take this opportunity to give a 5-minute break and also open this up to any questions you might have right now.
I have two questions. Considering that AI, AGI, has human understanding and reason, does it have biases? And how do you handle that? Then just explain the difference between the AGI and deep learning.
Does AI have biases? And if so, how do you handle it? And what's the difference between deep learning and AGI? Okay, so I'll answer the second question first, okay? Deep learning is a form of machine learning. Okay, deep learning in of itself cannot be compared to artificial general intelligence. Artificial general intelligence is a term that describes the behavior of the model that was trained using deep learning. Deep learning is a way of learning. That's all it is. You can deep learn a narrow AI model, or you can deep learn a broad AI model, right? But deep learning is just a form of learning. It's a form of engineering that is used to train these neural networks, okay? Now, AGI is just a broad form of artificial intelligence, very human-like in its behaviors and what its capabilities are. And narrow AI is like a chatbot or generative AI. That's that. Bias. Great question. That's the whole reason I got into reasoning models in the first place, and I never trained language models. I could have. I didn't have $100 million, I'll be honest. I couldn't afford it at the time when we were doing it. And I still don't have $100 million. But I decided that when you train on too much information, you introduce bias. Let me give you an example. If I only ever train on knowledge, and I only ever give American knowledge to my kid will not know that another country in the world exists outside of the borders of the United States. So I've inherently introduced bias, right? Because the amount of information I gave my child was limited to the books I allowed them to read. And if that's all they ever learned, right? So by default, that in of itself is bias. So limited training causes bias, and overfitting, also giving the wrong information, also causes bias. So what did OpenAI do to eliminate bias in that way? They just said, man, train on the whole damn internet. Whatever's out there, I guess that's the fact. Everything, right? And so as a result, they hope it's not biased. But sometimes biases get introduced when you give more data to it. So when people try to take a model, like you're in banking, right? So when somebody takes a model and gives, for example, your bank's information to it only, your model thinks that all of banking is whatever your bank does. That's a bias. I often say no to data. I tell people don't give more data. In fact, at the data governance panel speech I had yesterday, I said, I don't know what you guys are all talking about all this big data paranoia, right? We don't need more data in AI. You give us more data, you actually will bias our model. Because now what you're doing is it's like you've already taken your kid to school, the kid's got a PhD, now you're force feeding them more specialized information in that field of research, and now they'll never be able to do independent research because you've conditioned that child's brain to thinking and researching only one way. Now they can't do it another way, okay? So how we handle bias is we say no to data. Our models, and you'll see later, are designed to think, not to answer. So the way we think is like, what is the steps required to solve this problem, the multi-steps that it takes to solve the problem? And when we need data, we'll go get it, but we ourselves don't train on data. We train on theory of mind, not on books. So we don't have an inherent bias problem. We're just there to figure out what's the best way to solve the problem, not is it the best way to solve the problem using American medical practices or Kenyan medical practices or Kenyan laws, American laws. We don't introduce bias into it that way. So we don't have a bias issue with ours, ever. I've never seen a bias issue. And in fact, I've told cancer researchers, they've offered me their data for free. Said, take all our 20 years of research, help us come up with a better way to diagnose pancreatic cancer. I said, no, thank you. Don't give us your data. If you give it, we'll wind up using your broken research that you've been doing for 20 years and just researching down that same paradigm. And we want an independent theory. So leave us alone to figure it out on our own without your data. So that's how we deal with bias. We don't give it more data. We actually limit the data we give to it and let it reason to its own conclusions. If you take a child, an intelligent child, and you don't give them your opinion, right, they will reason to their own conclusion. But as parents, we often influence our children's decisions, right? By saying, we do it this way, our family does it this way, our country does it, and we're influencing. That's actually called manipulation, right? You're just trying to get your child to think the way you do, right? You're not leaving them to independently, freely think. With AI, I don't let it do that. I just give it the minimum amount of information it needs, to be able to reason to a conclusion, and that's it. Then it figures everything else out and so on.
Is it okay now? Okay, in relation to the diagnosis model, to the diagnosis model that you gave, I don't know how do you handle the sensitivity or the consciousness of the model, given the fact that maybe you say that it can send you to take an X-ray or maybe a CT scan or something, then it reads the image and gives me the diagnosis. I'm imagining I have a cancer at stage 4, and then the cancer stage 4, and then the model just tell me you have cancer stage 4. Then I collapse and die. How do you handle that, the consciousness, so that it doesn't tell me directly?
You bring up a really valid point. I was lecturing at a healthcare conference in Los Angeles last year in December. Weren't you there for that? Hello? Weren't you there at the December UPNA convention when that cancer oncologist didn't want to know the answer, right? So that's Sylvia. She's my chief of staff. Last year in December, I was lecturing at a physicians conference in Los Angeles, and there was a guy that got up on stage and he presented his product. And the product was he can take a picture of your eye, and the AI would tell, based upon something it saw in your eye, whether or not you have pancreatic cancer. Okay? And I don't know if you know this, but pancreatic cancer is one of the hardest cancers to diagnose because it's so embedded in your body. It's not visible, right? And by the time you capture it, you're already stage 4. So it's a leading killer of cancer, a leading killer of the humans. And so everybody's like, this is fantastic. And this one lady raises a hand, and she said exactly what you said. She goes, will never use your product, to the guy who was on stage. And he said, why? And she said, what you said. And I got furious. I stood up in the conference and I said, ma'am, do you mind if I talk? One of my physicians who works with us, Dr. Sana Khan, he's a radiologist. I said, do you mind if I handle this? He goes, sure, go ahead. So I got up, I said, ma'am, what's your name? She told me her name. I said, what is your specialty? She goes, I'm an oncologist. I said, as an oncologist, you're actually telling me that you don't want to know if your patient has cancer? You'd rather not know? She goes, yeah. I said, why? I was shocked. I said, why wouldn't you want to know? She goes, because, number one, if I tell them, they may actually not want to live anymore, and so they'll lose the will for life. I said, so as a result, you're telling me if you knew something for a fact, you wouldn't tell. She goes, I wouldn't tell. I said, you should lose your medical license. Because your job is to not make that decision for that patient. Your job is to use scientific evidence and tell the patient that they have cancer. You can't hold back information. Because if you hold back information, that's your bias. Your physician's bias. You're making a choice for your patients whether or not they should or should not know something. And you'll never know. Each one of you may be a patient right now. Maybe half of you want to know. Maybe half of you don't want to know. But how can I, as a doctor, make that choice for you? I'm a scientist. I'm a physician. I'm supposed to tell you if you're sick, and I'm supposed to tell you if you're healthy. Right? So as a physician, the physician has to be empowered with the best tools for diagnosis. But personally, I think, as an ethical human being, that we can't make that choice for somebody's life to tell them, sorry, buddy, you're stage 4. Maybe they're religious. Maybe religious people, I'm Muslim. Muslim people believe when your time has come, your time has come. You're going to die no matter stage 4 or stage 94. It doesn't matter. If you're dead, you're dead. If you're not dead, you're not dead. I don't give a damn if I'm stage 4 or stage 14. If my time has come, my time has come. I believe in God. Right? So I would just rather know that I'm stage 4. Thank you very much, because maybe I want to take care of my will and trust. Just in case I'm going to go, my kids should know. So it's an opinionated thing. That's the bias you're talking about. That question of hers alone is something we avoid to introduce bias in the system, because if we know something and we don't let that doctor know it, that is bias we've inherently implemented. Did I answer your question? Huh?
Yeah, just a follow-up to that. You know, it's not about the doctor. It's not about the doctor that you are telling. I'm imagining that the model is, that AI is talking directly to the patient. You know, okay, the culture is, you call the family, then maybe explain to the family that the patient here is suffering from something. Oh, so the AI talks to the...
Only the doctor works with the AI. The patient doesn't work directly.
Okay, now, to my last question, kindly. Now, it reads the images, and the AI depends on data. The AI depends on data, right? Not your AI. Okay. Let me talk of the vision transformers. You look at the image and maybe make a diagnosis. if you train that AI using a quality image, maybe your equipment are very powerful, then come to Kenya, that rural facility there, the equipment that we have might not even provide that quality of image. So how do you ensure that the quality of that image doesn't interfere with the decisions that are being made?
That is a problem with all AI out there today, except for ours. Okay, because of the way we've trained it. The AI that you're talking about, that's trained on images, is the same thing as the AI you're talking about, which is trained on knowledge, text. Okay, that form of AI engineering believes in the more images you give it, the more chances I'll find a tumor. It is a near-shot classification style of modeling. Okay, what that means is that if I give it bad data, right, it's not going to know that there's a tumor because it's never seen it before. When it did see it, the quality of the data was bad. We don't train that way. We have a unique patent called dynamic self-learning ontologies. He's the patent attorney who wrote it, okay, in America. Mark is actually a patent attorney. So dynamic self-learning ontologies uses the philosophy of ontological training. Meaning, give me the fundamentals, I'll figure everything else out on my own. Just don't give me all the... Because if you try to train in radiology, just take a look at MRI. MRIs slice in 3.5 millimeter increments, okay? 3.5 millimeters. Now, when you take a brain scan and the MRI goes around just the head alone, sometimes the images exceed 5,000 images just at 3.5 millimeters just to get the head. If you try to do it axial, sagittal, coronal views, which are the 3 dimensions of MRIs, for the whole human body, there's millions of images. And every human's different. The African genome is different than the white genome, is different than the Asian genome, is different. Our body structures are different, our bones are different. When an African bone cracks, the way it rebuilds itself is very different from the way the Asian does. They heal differently. Humans are different. Our DNA is different. You can't possibly take an image of every single human on the planet and hope and pray that you've captured every variable. You can't do that. I don't believe you can. And that is why these radiology systems that exist in healthcare today are really only good for lung x-rays, and that's it. They won't do spinal MRIs. Or they're these spinal MRIs, but they'll only work from the L5, S4 quadrant, and they don't go anywhere else. They won't do the hips because they've only been trained on that specialty. And they're only FDA compliant in the United States. They won't work in Egypt, for example, or in Pakistan. So, but when you train using SDLO, what you're really doing at that point is you're taking a reasoning model and you're saying, what is the basics of the human anatomy? How does the human body grow, right? And then how do lungs typically look? And does this particular nodule look like it's the exception to the rule? What exactly is happening to that nodule in your lung is up to the radiologist at the end of the day, or the doctor to look at, but it will flag it and say, that doesn't look right to me. I'm not going to tell you exactly what it is, right? Because I don't know, but I'll tell you it's not what the human body should be like. That's dynamic self-learning ontology. It'll learn, and as you keep using it, it becomes smarter and smarter. So the Kenyan radiology system will be more smart than for Kenyans than the LA system would be for Americans. This is going to go on for a very long time. You guys keep going with questions.
Yeah, so when we look at the internet and IP addresses when it started and how the internet started with the American Army, over time, they hadn't thought of the scalability, and that's why we've changed the type of IP addresses we're using, IPv4, IPv6. In AI right now, it looks like it's still not regulated, and it's growing. So is there any field that's looking at the impact of AI, not only from a job, what everyone is talking to, from a data, its growth? How is that growth going to impact the humanity in terms of resources? Have you researched that?
Any technology in the world, any technology, whether it's cryptocurrencies or banking software or healthcare software, at some point or the other winds up being regulated by some country, okay? This is a nascent technology. As I told you, AI has been around for a long time, right? But it didn't touch the everyday person before ChatGPT, so there's no need to regulate it. I mean, the AI in self-driving vehicles has always been regulated. Like in America, the Department of Transportation regulates autonomous vehicles, and then within each state they're regulated, right? But in terms of chatbots, they haven't been regulated yet, okay? Will it be regulated? I'm sure. Will the consumer allow the regulation? I'm pretty sure they won't. The same reason why the United States of America has not been able to block Bitcoin and even though the United States Treasury Department tried really hard, they couldn't, is because there was just too much damn demand for it. Okay? I was born and raised in Pakistan. I left the country when I was 20 years old. I've lived in the States for 35 years, but I'll tell you that Pakistan has tried to regulate use of social media by putting a national level firewall. Guess what the users did? They got past it with VPNs. The UAE tried it too. They regulate access to pornography or access to YouTube. China tried to regulate people bypass it with VPNs, so now they enact laws. So you can't regulate tech when the masses want it. There's just nothing you can do. At some point, they'll find a way to get the tech. AI is so disruptive, so utterly disruptive, that 5-year-old kids are using it, grandparents are using it, doctors are using it, lawyers are using it, real estate people are using it, bankers are using it. My CFO uses it. He balances my balance sheet all the time with using AI. How do you say no to something that disruptively good to society? Now, the only time you want to regulate something if it can hurt somebody. So in healthcare, yeah, AI is regulated in healthcare. At least in the United States, it's regulated. It's regulated for privacy through HIPAA laws. It's regulated if it is an autonomous system, meaning if it's a black box, right? Like your blood pressure machine's a black box. You don't know how it works, but you have to rely on it, right? Then it becomes a medical device and you have to go through regulation. But if it's a decision support system, meaning at the end of the day, the doctor makes a decision, it just helps you, it's unregulated, right? So when it touches on somebody's lives, it's regulated. Otherwise, general purpose, you simply can't regulate it. So the answer of regulation, I don't know if they'll bring it in, but I really don't see the world regulating AI. They put a moratorium on AI research in, I think, 2019 in the European Union. Tomas Fitzer was a PhD. He's a researcher at Google right now. He's a young guy. He's in his late 20s. At the time, he was in his early 20s. He was a PhD student at Oxford. And the European Union put a block on AI research. And Tomas said, what the hell are you guys doing? He went and spoke to the EU guys and said, you're basically sending humans backwards. And he convinced the EU to lift the ban, and the moratorium was lifted. They tried it in America. I don't know if you guys heard it. Bill Gates and all these guys put out this open letter saying, stop AI research, and nothing ever happened. In fact, America is the biggest investor in AI right now with about $1.5 trillion in AI data centers. So I don't see how the government invests, or at least raises, $1.5 trillion of money to build the world's largest data centers and then turn around and regulate that same thing. I don't think so. But it's possible. In terms of data, again, I told you earlier, right? I mean, data is data. You can't control data any more than you can control people sending emails out or using social media, because that's all data too. I was in like the panel speech yesterday where they were talking about data governance. Like, how do you govern data for how many people? What's the population of Kenya? 15 million people? 50 million people. 50. What percentage of Kenya do you think uses Facebook, Instagram, TikTok, WhatsApp? Probably half. Got to be in some way, right? Email, probably 70%. WhatsApp. How do you stop 50 million people from using social media? Because I'm telling you, they're putting their data out there. Where they ate food, what car they own, what house they live in, what job they have. All your national data is being put out by the citizens themselves in the cloud, right? How do you stop that? So how does a country govern their data and say, let me put barriers on my data when the citizens themselves are putting the data on the cloud? You can't police every single citizen. Don't send an email. Don't save a Word document in Google Drive. Don't use social media. Don't tell the planet that you have a Mercedes-Benz. Don't show your lifestyle. Don't speak about your illnesses. Don't talk about your recent divorce. This is national level data, right? How the hell do you prevent that from happening? You can't. So this whole data governance thing drives me nuts. I can't believe people are actually trying to govern national level data. Can't do it. Not making sense. Can we take a 5-minute break? 1 second.
Yeah, thank you. Evelyn, 2 questions, and could be very not related, but a bit, yeah, with what the rest asked earlier. And I would want to understand, how are you ensuring that the usage of AI does not interfere, or rather replace human creativity and critical thinking? Because you will find, for example, in the workplace, yes, you have a solution that someone can use very well and get fantastic results. However, they just have the art of using, they understand the art, but in terms of critical thinking, creativity, how do you ensure you get the right people still, and not the people that have used AI to get to that? The second question, yes, is on still on biases, but specifically around the understanding of the context and environment, learning. How do you again ensure that you're not misinterpreting the environment. And it could be from the physical environment to emotional environment to the context itself of the matter before you interpret whatever data you've already gathered and given a verdict.
Thank you. Okay, so first question, how do we prevent people from becoming stupid by using AI? And the second question is, how do you make mistakes on the data? First question was, how do we prevent humans from becoming stupid by too much use of AI? And the second question is, how do we misinterpret the data? Okay, Microsoft could not prevent people from becoming terrible spellers when they introduced spell check, okay? I am the worst speller in the world, I promise you. I can't spell when I type because I've just been using spell check for the last 20 years. And I really don't care. I don't care if I know how to spell. As long as I can send my email out, you could read it. I don't really care if I'm the world's greatest speller. Okay, I don't care. It's irrelevant to me. But the point is, can I author a document and will the damn thing spell it for me? Spell it for me, okay? My wife sits there and tells me, oh, we've lost the art of penmanship. When I was growing up in the UK, we had beautiful calligraphy writing. I'm like, who cares? It takes you 1 hour to author the document. Just talk to the damn thing. Man, it'll write your email for you. What is with this art and craft that you guys, nostalgia, is trying to hold on to spell checking and stop spell checking and start writing? It's like, okay, get out of the Stone Ages, guys. I mean, it's spell check now, right? So same thing with AI. I can't help it if people become stupid. That's not my job, right? My job is to give you a tool that'll help diagnose the patient better and probably save a life or avoid a drug interaction from accidentally happening because human physicians make mistakes all the time by prescribing two drugs that interact with each other, or maybe give a divorced woman a woman going through a divorce in a developing nation where she's been dependent upon her husband all her life. Now suddenly she has AI in her hands. She can fight him in a divorce battle and get alimony out of him. I'm trying to do AI because I'm trying to make sure people make the right decisions with their investments. I'm trying to give AI so people make the right decision whether should they buy that house over here or not. Will they make money, lose money, credit risk analysis, insurance, those kinds of things. And if along the while there are a bunch of people that grow up and say, you know what, I don't want to think anymore. I would rather this thing do it for me because I want to go play golf. I'm sick of thinking. I'm telling you I'm sick of thinking. Huh? What's that?
How do you ensure that you're not picking me, who is just AI savvy, and him who is creative, who is intelligent, and can do things independently out of, imagine, without using the AI. But now because I've used the AI and I look smart, then you're biased to picking me, for example, for a job or for a task.
So AI is becoming a critical skill in the job place. If you guys think right now that, I don't know if it's made it here to Kenya yet, but if you think right now AI is not a critical skill in the job place, you're sadly mistaken. It just hasn't found its way here. I'll tell you right now in America, if you're not using AI, they're not hiring you, period. I'll tell you in my own company, I don't care what college degree you have. It's irrelevant to me. If you know how to use AI, you've got a job. Case in point, there was a security guard. Okay? He's a refugee from Ethiopia. His name is Binyan Ephraim. Binyan is how old? 25? 26? 22? He's 22 years old, Ethiopian refugee, was a security guard in the high-rise building I live in downstairs. He said, boss, can I please get a job as an IT support person? I said, I don't need, our AI does IT support. I don't need an IT support person. But he had, I think he's 25. He had passion. That kid was creative. He was cool looking too in nice dreads. He looked cool, looked like a total engineer. But he had a lot of passion. He wanted to do something with his life. And he didn't want to be a security guard in my building. I hired Binyan Ephraim. And I taught Binyan Ephraim how to use AI to write software. Today, Binyan Ephraim is a developer and engineer in my company. There's a AI-powered e-learning platform we created called Arthur AI. Binyan was one of the lead developers on it. He was smart. He learned quickly how to use AI. He was passionate. He wanted to do something for himself. His brothers and sisters still live in Addis Ababa. He wanted to send money home. He is one of my best developers I have in the company right now because he used AI. He has no college degree. He never graduated high school. He learned nothing in America. His English is so bad he can't write an email. His spelling is terrible. But he uses AI, ChatGPT. So he writes whatever he wants to write in Ethiopian, whatever language, and outputs it in English. And he shoots email off to HR like the guy just got out of Harvard University. Can somebody get Binyan on WhatsApp or something? What time is it in America? Show him, talk to Binyan. Huh? So who cares? Look, but smarts does not mean knowledge. Do not confuse knowledge and intelligence. I never went to college. I dropped out second semester Boston University. I dropped out of college. I said, this is for the birds. I don't want to go through school for 4 years just to get some piece of paper. I think I'm generally intelligent. I'll figure anything out. Don't mistake knowledge with intelligence. You should always hire intelligent people in your company, but they don't need a degree to prove that they're intelligent. A degree just says that you have a certain degree of knowledge in a field, and with some accredited university, you have been given a certificate from that university that says this person is certified to know chemistry to a bachelor's level, right? And if I'm a pharmaceutical company, I need chemists, so I'm going to go hire that person with that piece of paper, right? But that doesn't mean to say that person's intelligent. This person may have learned chemistry, is utterly inept at chemistry, may be using chemistry to make crystal meth in a backyard, right? Maybe it's not good for medicine. I don't know. But intelligent people will still always have a place in the workforce. Intelligent people, even average intelligence people, will always have a place in the workforce just like they did in the past. What AI does is it neutralizes the knowledge bar. Now it doesn't matter if you went to school in India or Yale University for law, you're both the same because the amount of power you have in your hands with AI, it equalizes you. And you'll see in a second. Can I take a 5-minute break? Any more questions?
No. Excuse me. We're about done for time. So, Bill, we have to... Yes, please do that. I think they don't need a break.
A 5-minute break. 5-minute break, okay? I'm not done with this.
I know that. I'm just trying to be cognizant of time because the next presenter is also here in terms of that switchover. So, do you promise then to
Give
not...
me 15 more minutes. 15.
Okay.
15, okay?
Yes. Excellent.
Okay.
Execute the logic in a step-by-step way and come to a conclusion and give you that answer. That's called reason. Ideation, solutioning, planning, and execution all wrapped into one knockout punch solution. We're trying to treat patients by empowering physicians. We're trying to improve legal outcomes by empowering attorneys. Fairness. Fairness. Something that allows everybody to have the best healthcare, the best legal representation, the best financial solutions, and the best solutions. Ava creates hope at scale every single day. And Ava's group of agents creates hope every single day. Equalizer.
That's Ava. That is the first agent that I created 2 years ago, 6 months after I discovered artificial general intelligence. And this is an old picture, but it's actually in color for dramatics. We made it black and white. But that's just a picture of her we created then using a diffusion engine as to what she looked like. And that's her. Next slide. I'm going to go through this quickly. Please watch this. Okay, I'm going to go through this quick. So that's Ava. That's our agent, the core reasoning agent. That is actually a 3D model of her. We've actually done it with our augmented reality, virtual reality team using meta technologies. We've actually activated her. She behaves like a human. She talks like a human. She has body movements like a human. And she is not an avatar. She is a 3D model. And just like Ava, we have these other agents. But this is a little bit about her. I know I got 10 minutes. Just throw me up a finger 5 minutes, okay? But basically, Ava's not a chatbot. These are some misconceptions about our agents versus ChatGPT. So, ChatGPT style assistant misconception: Ava is not a chatbot trained for generic conversations. Pre-trained text predictor: Ava does not rely on next word prediction for fluency. She uses structured reasoning. ChatGPT uses next word prediction, transformer architecture. One size fits all LLM. It's a misconception. People think that's what our models are about. No. Ava's models are domain specific, meaning healthcare, real estate, all these verticals. Domain specific, agent driven, logic tuned, not general purpose text generators. People think it's a prompt mirror, like ChatGPT, prompted mirrors back an answer. Ava doesn't simply mirror user input. She deconstructs, interprets, simulates, and adapts with intention for what you want, making her brain very different. Next slide, please. What Ava actually is, the core principle: she is a reasoner, not a responder, which is what ChatGPT is. Ava models simulate cognition using symbolic logic, causal inference. I told you, right? You can infer something. You give it an image of a picture, it can infer what's wrong with you. It's causal inference and executive intent parsing. She's trained on logic, not language. I said later I'll discuss with you philosophical reasoning data sets. Okay, that's the logic we embed in the model, not the language of the textbooks. Okay, Ava's models use synthetic reasoning data sets, not text scraped from the internet. In genetic intelligence, each Ava model, example Justine for law, Chiron for the doctor, Eli the financial person, is purpose-built, domain-aligned, and scenario-trained. Cognitive scaffolding, agents apply hierarchical reasoning, decision trees, and memory synthesis, not flat token prediction. And operationally deployable, Ava integrates into enterprise workflows as a decision partner, not a conversation tool. Next slide, please. Okay, so this is the difference between our suite of F4 is the series that we're at right now, Fusion 4. We went to 1, to 2, to 3, to 4. We're releasing Fusion 5. The reasoners, compared to, say, ChatGPT or other open large language models. The core objective, we're domain-specific reasoning and decision support. They're general-purpose text generation. Our training data is synthetic, logic-rich, curated by domain. They are web-scale, natural language corpuses of text. Memory systems, we use vectorized symbolic continuity memory. We never forget. They use token window memory. Our output type is simulated reasoning, synthetic thought, strategy, compliance. They're fluent but surface level responses they give you. Deployment role, embedded AGI agent in operations and workflows. They're web-based, usually quality question answer tools. Architecture layering, we use neurosymbolic reasoning, hierarchical reasoning. They use strictly transformer architecture. Next. Thinking is not guessing. Ava's reasoning under uncertainty. Ava's a cognitive engine. She's designed to think strategically, reason, executive alignment with whatever your business is. Her agents are not conversational clones, and they are intelligence systems. They're designed to think with you, not talk back at you and answer your questions. Next. Ava's technology, real quick. She thinks and reasons using transformers, language models, orchestration, and deep learning. She continuously learns using transfer learning, and she can predict any outcome. She can predict if you're going to get sick, if you're going to die, if you're going to survive, if you're going to win the case, if this investment is going to make money, lose money, whatever. All the predictions are done using machine learning. Next. How does she think? I won't go deep into this. How much time do I have left? 5 minutes? Huh? 5 minutes? Okay, good. We'll get to this later, but she basically specializes in zero-shot classification. OpenAI, all these other guys, they specialize in near-shot classification, meaning they train on all this knowledge, and if you ask them a question, they can find it anywhere in their memory, something similar. They'll try their best to answer it. And if you ask them a question that they've never seen before, they hallucinate. The way we avoid hallucination is we specialize in zero-shot classification, meaning we can think through any problem and give you a cohesive response. And we can do it using these 5 steps. Next. How does she reason? So when you try to come to a conclusion, you first have to think about the problem. Then as humans, we solve the problem. She reasons using a dynamic chain of thought. So basically, much like humans, when we think, okay, I got to do this. I got to do this first, that, and then that. Okay, that'll solve the problem. Well, that's called chain of thought in AI. We use dynamic chain of thought. Our chain of thought changes depending upon the problem. Okay? So it's dynamic. And it uses these 6 ways to do it: pattern recognition, logical deduction, so on and so forth. Next slide. Her large reasoning model. So everybody else in the world makes large language models. We make large reasoning models. And we use a combination of transformer architecture, pre-trained language models, attention mechanisms, fine-tuning, probability-based pattern reasoning, and context retention and memory synthesis. This is going to get very deep, so I'll skip through it later. It's heavy engineering. This is some of our expert model series. Ava Healthcare is the one that lady was asking about. That's the reasoning model for medicine. The agent is Chiron. He behaves like a doctor. His domains are clinical, medtech, health intelligence. Roughly about 280 billion tokens of reasoning, trained on 54 billion parameters. Ava Legal is the law model. The agent is Justine. About 62 billion parameters. Ava Real Estate. The agent is Teresa. Ava Insurance. The insurance broker is Isaac. Ava Education. The professor is Arthur. Ava Finance. The financial guru is Eli. Next. Ava Retail for, basically Shopify front ends, those kinds of things. The agent is Carter. Ava Marketing, used heavily for social media marketing, running ads, creating content. In fact, a lot of my marketing stuff, even my speeches and stuff, is often used using Sage. She authors a lot of our marketing for our company. Theology is on religion. He does religious studies, ethics, and interfaith systems. About 190 billion parameters there. And Ava Technology is Skylar. It can do IT, cybersecurity, code, cloud. I mean, anything you want. If you're basically an IT person, Skylar is like your best friend in the world. These are the 10 models we've got next. And that's us. I just want to give a special thanks to Mary. I was in Islamabad, Pakistan a couple of weeks ago at a big tech conference there, and I gave one of the speeches, and I met with Mary briefly. The next morning I was having breakfast, and Mary sat down at the table next to me, and I invited her to join us at the table. We became very good friends, and she said, "Why don't you come to Kenya, my country?" And I said, "Invite me," and she did. And so I brought my whole team. That's Kevin Welsh, our head of business development, Mark Hopkins, head of agentic strategy, Sylvia is my chief of staff, Obed is our AI ML engineer, and Mary is our best friend in Kenya.